In episode 45 of the CySec101 training series, we are going to go through the fundamentals of a firewall. And the firewall is the first line of defense inside of any network or in any computer. And this is a part of the security solutions module, which is a part of the cybersecurity 101 pathway of TryHackMe. And inside of this video, we're going to go through these topics. We have what is the purpose of a firewall, the various types of firewalls, the rules in firewalls, the Windows Defender firewall, which is actually an exercise that we're going to run. It actually has a virtual machine that's attached to it. And then the Linux iptables firewall, which we actually did cover in depth inside of the Linux Plus training series. So you can actually go find that playlist, and it's a pretty popular playlist. So you can find the iptables firewall and the various commands to run it, to create rules for it, so on and so forth. And so this is it. This is the video that we're going to be covering today, and I'm excited about it because this is a very important tool, and I think you're going to get a lot out of it, especially if you've never seen firewalls before and if you've never used firewalls or anything like that. So I think this is going to be a good one. I'm excited to share it with you. If you'd like to support this channel and get access to me on Discord, consider joining the Hackaholics Anonymous community. We have 4 tiers: the supporter, agent, guardian, and master, and each tier gets their own Discord server as well as early access to content, and the agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, bug bounties, live streams with me, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@hankhackshackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let's jump into the firewall fundamentals room. So what is the purpose of a firewall? We've seen security guards outside of shopping malls, banks, restaurants, and houses. These guards are placed at the entrances of these areas to keep a check on people coming in or going out. And the purpose of maintaining this check is to ensure that nobody sneaks in without being permitted. That's the job of a security guard or a security team, right? Or, a physical security guard team. This guard acts as a wall between his area and the visitors, and a lot of incoming and outgoing traffic flows daily between our digital devices and the internet that they are connected to. So what if somebody sneaks in between this massive traffic without getting caught? We would also need a security guard for our digital devices who can check the data coming in and going out of them. And this security guard is what we call a firewall. A firewall is designed to inspect a network or digital devices incoming and outgoing traffic, and the goal is to be the same as for the security guard that's sitting outside of a building, to not let any unauthorized visitors enter a system or a network. So you can instruct the firewall by giving it rules to check against all of the traffic, and anything that comes in or goes out of your device or your network would face the firewall first. So it is the first line of defense in a lot of cases. And so the firewall will allow or deny that traffic based on the maintained rules that it has. And most firewalls today go beyond rule-based features and filtering, and they offer extra functionalities to protect your device or your network from the outside world. And we're going to talk about these when we actually talk about the various types of firewalls. And we have this wonderful image. I love images. They take everything that I just said and basically put it into one memorable visual. So what you can see is you have the wall that's on fire. I wonder where that name even came from. Like, what is the firewall? Well, I think it's like the wall that's under fire. Maybe that's what it means. Like, it's under attack. So it's if something is under fire, that means there's like a constant flow of attack happening against it. Maybe that's what it is. So we have unwanted traffic that's trying to get into the network right here, and then we have the traffic that's leaving the network, and obviously that goes through the firewall and it's allowed to leave. And then you have all the unwanted traffic coming from this cloud, from this ether, from the internet that's trying to get in, and it's being blocked by the firewall. So the objectives here are the learning about the different types of firewalls, the firewall rules and the components of a rule, the hands-on Windows built-in firewall, and of course the hands-on Linux built-in firewall, also known as iptables. So you do need a basic understanding of networking if you have not seen the networking videos, or if you haven't gone through the networking concepts video that we did, or recently we just came out with Network Plus. So if you haven't gone through the Network Plus playlist that I just uploaded this last week, I highly recommend you go through that because you do need a good understanding of networking. Not really crazy stuff, because we're not going to be going really into like really the weeds of it or the deep end of it, but it's good enough to know. It's good always to know about networking, because everything that has to do with cybersecurity also has a layer of networking in everything that we do. So it's always good to know those things. So which security solution inspects the incoming and outgoing traffic? And of course, we're talking about firewalls. So Firewall is the answer here. All right, let's go to the types of firewalls. So when companies and organizations found out that firewalls can actually filter harmful traffic from their systems and networks, firewalls became super popular and very common. And it's pretty much, it's a foregone conclusion. I feel like every organization, I can't imagine an organization that doesn't have one. I mean, like, most computers come pre-installed with a firewall, and the firewall is always turned on and trying to detect malicious traffic anyway. So like, I just can't imagine that a firewall would not exist in an environment. It would be really rare, like really, really rare to find something that doesn't have a firewall in it. Or like a network that doesn't have a firewall. It doesn't sound right. There are different types of firewalls that were introduced after the very first one, and each of them serve a unique purpose. And it's also important to note that different types of firewalls work on different OSI model layers. So this is the networking element that comes in. So we have 7 layers of the OSI model, and each layer technically could have a certain type of firewall that's associated with it. There are many types of firewalls. The main ones are the stateless, stateful, next generation, and then proxy firewalls. So these are the 4 main categories of firewalls that we're going to cover, and these are the 4 main categories of firewalls that you will most likely run across. And there you most likely have something like this, or a combination of these things that actually is pre-installed on your machine that you don't even know about, that is just running in the background and protecting you. So firewalls are, again, very important, and these are the 4 types. So stateless, and this is the type of firewall that runs on layer 3 and layer 4. So layer 3 would be our network layer, layer 4 would be the transport layer of the OSI model, and they work solely by filtering the data based on predetermined rules without taking note of the state of the previous connections. This means that it'll match every packet with the rules, regardless of whether it's part of the legitimate connection. So it maintains no information on the state of the previous connections to make decisions for future packets. Due to this, these firewalls can process the packets quickly. However, they can't apply complex policies to the data based on their relationship with previous connections. Suppose the firewall denies a few packets from a single source based on its rules. Ideally, it should drop all future packets from the source because the previous packets could not comply with the firewall rules. However, the firewall keeps forgetting this, and future packets from the source will be treated as new matched by the rules again. So this is strictly rule-based. So if you want to think about stateless, you can think just a rule-based firewall. It doesn't have context, or it doesn't understand previous connections, memories of any previous activities, or anything like that. It's just based on rules. And it's, think about it like this, right? You have the guard that's sitting at the front of the building, and you've shown him your ID, right? And you show him your ID every single day that you go to work. And by month 1, he's seen you every single day. He knows you by name. He knows exactly who you are, what department you work, all of that. But every single time you show up, he's like, I got to see your ID or I can't let you in. I got to see your ID or I can't let you in. I got to see your ID or I can't let you in. That's kind of what it's like. It's so rule-based that it doesn't remember any of the context of previous connections or any kind of a relationship with the traffic that's going in or out, right? So it's just rule-based. Stateless doesn't remember the state of previous connections. It's stateless. It's just rule-based. Stateful, however, is the type of firewall that goes beyond filtering packets by the predetermined rules. So it also keeps track of previous connections and stores them in a state table. And this adds another layer of security by inspecting the packets based on their history with connections. Stateful firewalls operate at layer 3 and layer 4 of the OSI model, like the stateless. And suppose the firewall accepts a few packets from a source address based on its rules. In that case, it will take note of this connection when it's stated table or in its stated table, and allow all the future packets for this connection to automatically get allowed without inspecting each of them. So think about the security guard example. After seeing you for a month or two, now he recognizes you and he'll let you go in, right? Similarly, the stateful firewall takes note of the connections for which they deny a few packets, and based on that, they deny all the subsequent packets coming from the same source. So it remembers previous relationships, previous connections. Now, this can actually kind of get a little bit tricky, because if it accepts a few packets based on a source and based on its rules, so it says, oh, this IP address is fine, and somebody can disguise themselves as that address, then that person can now get in. So it's like somebody wearing a mask that looks identical to you, pretending to be you, and walks in and they're like, oh shit, I forgot my IP or my ID, excuse me. And the guard's like, oh, don't worry about it. I know you, Mrs. Johnson. You know what I'm saying? And that can get a little bit tricky. And of course, we need something that can take care of that can address that as well. Then the next one is going to be the proxy firewall. So the problem with all of these is that their inability to inspect the contents of a packet. So proxy firewalls or application level gateways act as an intermediary between the private network and the internet, and they operate on the OSI model's layer 7. So layer 7 has to do with the application, right? So this is an application level gateway. So this specific type of firewall operates on layer 7. They inspect the content of all the packets as well, and the requests made by users in a network are forwarded by this proxy after this inspection and masks them with their own IP address, and to provide anonymity for the internal IP addresses. So content filtering policies can be applied to these firewalls to allow or deny incoming and outgoing traffic based on their content. So that's another extra piece that goes right here. But think about a proxy, right? What does a proxy do? So if I have a proxy between me and, if let's say we're thinking about a pen test source, right, or a pen test exercise, I use my IP address to first connect through the proxy, and the proxy disguises my IP address as a different IP address, so that when I finally do whatever activity I have against my target, the target sees the address of my proxy. It doesn't see mine, because mine is now disguised through the proxy. So this is what it does for us. It actually makes it so that the requests made by users in a network are forwarded after inspection and masked with their own IP address to provide anonymity for the internal IP address. So as you communicate with the external world, you don't want your actual device's IP address to show up on the internet. So this is why we have these types of firewalls in place. And then there's also something called the network address translation protocol that also does something like this. And this is also kind of like pre-configured. And for the most part, in a lot of cases, your internet service provider will do something like this for you as well, where your private IP address is disguised, right? It's masked with a public IP address, so that as you roam around in the internet, people don't know what your actual IP address is, and they can't scan you or capture your packets based on that information, or try to impersonate you based on that information. So that's why proxy firewalls are very important. And finally, we have the next generation firewall. So this is the most advanced type of firewall that operates from layer 3 to layer 7 of the OSI model. So it goes all the way, right? So it goes through the network layer, the transport layer, the presentation layer, the session layer, and of course the application layer. So it goes through all of those layers, and it offers deep packet inspection and other functionalities that enhance the security of incoming and outgoing network traffic. It has an intrusion prevention system that blocks malicious activities in real time. So instead of just detecting something, it actually prevents it from furthering its goals or furthering its connection and its grasp on your device or your network. It offers heuristic analysis, which is signature-based, and it analyzes the patterns of attack by blocking them instantly before reaching the network. So it basically looks at the signature of an attack and says, oh, this is, I have a massive database of threat intelligence, and I recognize this signature, so I know that you're an attack or something that's trying to do some damage to my network. You're definitely not getting it. And so next generation firewalls have SSL TLS decryption capabilities, which inspect the packets after decrypting them and correlate the data with the threat intelligence feeds to make efficient decisions. And this is the firewall's characteristics compared to each other. So this table compares all of them to each other. And I'm not going to go through all this because we really went through the depths of these details right here. So feel free to pause it to go through each one of these comparisons if you want to. But that's it. This is all of the various types of firewalls that we have available at our disposal. So here's the question. Which type of firewall maintains the state of connection? So it is not stateless, right? It maintains the state. So that would be what? A stateful firewall. So let me, there we go, stateful firewall. Which type of firewall offers heuristic analysis for the traffic? So this is the type of firewall that actually remembers the signature of the traffic, right? So that would be the next generation, like that, firewall. Which type of firewall inspects the traffic coming to an application, which is the application level, and that would be the proxy firewall. And we are good. So let's go talk about the rules that are in these firewalls. There are built-in rules that come with firewalls, and then there are ways that we can customize our rules for various types of networks. So there could be networks that want to deny all SSH traffic that come into the network. However, your network would have a requirement to allow SSH traffic from a few specific IP addresses for your administrators or your security team. So the rules allow you to configure these customized settings for the network's incoming and outgoing traffic. The basic components of a rule are this. We have a source and destination address. So the machine's IP address that would originate the traffic and the machine's IP address that would receive that data. And then the port number that's going to be used, the type of protocol that's going to be used. So is it going to be TCP or UDP? What's the action that's supposed to be taken? And usually it's either allow or deny. Those are the basic actions that can be taken. Sometimes there is drop, meaning drop the connection. Sometimes it could be block, to actually block that IP address, add them to your block list. And then the direction, which defines the rule's applicability to incoming or outgoing. So you could have a direction being any, so meaning from any direction, either incoming or outgoing, I want you to block this specific IP address. So whether it's the source address or the destination address, I don't care. Or you could say, any source address or any destination address from any direction, I need you to block it if it's trying to access port number 22, right, which is SSH, right? That could be it. So you're going to do that, and then you would create something called an explicit allowance. So you're explicitly going to say, I'm going to allow this one IP address to access my SSH port. Apart from that, all access to this port is denied. Okay, automatically every single other IP address is denied with the exception of this one address. So technically you're creating two rules. One of them is going to be deny everything, and then the second rule is going to be allow this one IP address, right? So the types of actions that you could take, it could be allow. So the allow action indicates that the particular traffic defined inside the rule would be permitted. So an action to allow all outgoing traffic from our network on port 80, basically used to access the internet because HTTP traffic goes on port 80. So you're going to allow anything from this subnet. So we have 192.168.1 is our network, and then this 0 represents the hosts on our network. So it could be 100 different computers that we have, or whatever, 100 different IP addresses. So anything from this subnet can reach any destination using the TCP protocol on port 80, and it's going out. So that's allowed. So all these computers can access the internet, right? A deny rule means that the traffic defined inside the rule would be blocked and not permitted, and they're fundamental for the security team to deny specific traffic coming from malicious IP addresses and create more rules to reduce threat surface of the network. So now we're creating a rule to deny all the traffic on port 22, which is used to secure shell, to securely remotely connect to a computer. So we're going to deny from any IP address to this subnet TCP port 22, which is inbound traffic. This is the rule. right? So notice, this is the same subnet that is the source, and the destination would be any, and then on port 80, it's allowed. As far as the source, meaning any other IP address that's outside of us, if it's the source of the traffic is from those IP addresses and is coming into our subnet, the destination is our subnet, and they want to come through port 22, we are not allowing them. The inbound traffic on that is not allowed. Forward redirects the traffic to a different network segment using the forwarding rules, and this applies to firewalls that actually provide routing functionality and act as a gateway between different network segments. So it's essentially a firewall and a router, so that traffic comes in and then it'll route it to different parts of your network. So we want to forward all incoming traffic on port 80 to the web server of 192.168.1.8, right? So it's still our subnet, and then we have this specific IP address dedicated to the web server. So forward any source to this IP address on port 80 that's inbound, right? So any incoming traffic, doesn't matter what source is coming from, is going to go to that web server if it's coming on port 80. The directionality of rules, which is basically the direction that it's going. So is it incoming or outgoing, right? That's basically all you need to know. And the image is, I mean, it's this one's kind of easy to understand, right? So if the traffic is coming from the internet and it's coming to your network, it is inbound. It is incoming traffic. If it's leaving your network and it's going to the internet, that is outgoing traffic. And so this traffic would be filtered through the firewall in either direction, right? So if it's coming from the internet, the firewall is going to filter it, and based on its rules, it's going to allow a certain type of traffic to reach your network. If it's going out, it's still going to filter that traffic, and based on the rules, it's going to do certain things to allow that to take place. Now, what's very interesting is that firewalls can also be used to limit your users' access to certain websites. So let's say you don't want them to access a given IP address, right? You don't want them to access the IP address of, I don't know, a porn site. Let's say you don't want people to watch porn while they're at work. You don't want people to watch Netflix, and that went like malicious. So you don't want them to watch Netflix, right? You don't want them to watch streaming services. It's like, okay, well, you shouldn't be able to access Netflix from your work device. It's kind of important that you focus on work while you're at work, right? That's the basic rule that you can set for outgoing traffic from your work network. So inbound rules are categorized as inbound when they are meant to be applied to incoming traffic only. For example, you might allow incoming traffic on port 80 to your web server. Outbound rules are made for outgoing traffic, blocking all outgoing SMTP traffic, which is on port 25 from all of the devices except the mail server. So SMTP is the Simple Mail Transfer Protocol. And so all outgoing traffic on port 25 would be blocked except if that traffic is going from the mail server. So this is the rule. The source would be the mail server IP address. Destination would be any TCP protocol port 25, and it would be outbound, outgoing. So forward rules are created to forward specific traffic inside the network. For example, a forwarding rule can be created to forward the incoming HTTP port 80 traffic to the web server located in your network. All right. Now, which type of action should be defined in a rule to permit any traffic? If it were permitting them, that means we are allowing them. What is the direction of the rule that is created for traffic leaving our network? And that would be outbound traffic. It's leaving, it's outgoing. So now we get to actually look at the Windows Defender Firewall, which is the firewall that is on Windows. You guessed it. So let's check it out. Okay, so we have a bunch of screenshots and a bunch of instructions to actually go through the firewall on the Windows machine. But instead of going through all the screenshots, I would much rather just show you the machine itself. And we can go through the Windows Defender Firewall on the virtual machine that we have, which is right here. So based on this instructions, we're just going to run everything on that machine. And then we actually do have a couple of questions at the very end right here that we're supposed to retrieve from the Windows Defender firewall that we got. So let's do it that way. I'm going to pull this off and we're going to move it to a different screen. I'm going to move it to my secondary monitor. And then from this monitor, we're going to read the instructions, and then on the monitor that you see in front of you, we're going to actually run the exercise. So the very first part of this is to open up the Windows Defender firewall. And so easily we can just go right here, we can click search, and then from there we will search for Windows. If I spell it correctly, I think I clicked on a few different things that I shouldn't have. So Windows Defender, I could probably do that. And it should bring up the Windows Defender. And there it is. So actually we have Windows PowerShell. Oh, there we go. Windows Defender with advanced security. All right, cool beans. So here it is. This is the Windows Defender firewall, and it looks very fancy. Not really. This is basically the interface for essentially anything that we have on Windows. Looks like this. So the Windows Event Viewer looks like this, and almost everything that's on Windows looks like this. So we have on our left pane right here, we have these various profiles. So we have the inbound rules, the outbound rules, connection security rules, and we have the monitoring section. On the right, we have the actions pane, and this is also very similar to the event viewer. So this almost like looks identical to what the event viewer on Windows looks like. So on the very on the very left hand side, we have the Windows Event Defender firewall with advanced security. These are the elements here. I think I'm not even supposed to be on this one. I think the display that they originally had for us is for the version that or like the entry point that is through the control panel. So I don't think that this is the one that they even wanted me to find. So I'm actually just going to open up the control panel, and I'm going to go to System and Security to show you the one that they wanted us to find, because I automatically jumped into the Windows Defender firewall with advanced security, and that's not the one that they want. So right under here, so when we open up control panel, the very first one is System and Security, and then when we go to System and Security, we have Windows Defender firewall, and this is the path that they wanted me to take, because this is what the actual screenshot looks like. So right off the bat, we see that we have a couple of profiles over here. We have the private networks that are not connected. We have guest or public networks that are connected. We also have the control panel home on the left side, allow an app or feature through the Windows Defender firewall, change notification settings, turn Windows Defender firewall on or off, restore defaults, advanced settings, and of course troubleshoot the network. So these are the elements that you see right here. So let's go through each one of these step by step. So in the center, the biggest pieces that we see right here are the private and the guest or public network profiles. So the private one right here, if we can drop this down here, this is basically the firewall configurations to apply when you're connected to your home network, okay? And I guess in this particular case, I'm not connected to my home network, so it actually shows it. It is on incoming connections, block all connections to apps that are not on the list of allowed apps. Active private networks are none. Notification state, do not notify me when Windows Defender Firewall blocks a new app. So that is the private network, and this is again configurations that you want to connect to your home network. And then you have the guest or public network, and this is the configurations when you're connected to a public or untrusted network like a coffee shop or a restaurant or something like that. And for example, when you connect to these things, you can configure the firewall settings to block all the incoming traffic network connections and allow only some of the outgoing connections that are essential for you. So for example, you want to access the websites, right? So HTTP traffic you want to be able to access, which is outgoing, and you need that because you're connecting to a coffee shop, right? That kind of stuff. But anything that's incoming, you want to block, right? So in this particular case, this is also on for us, and we've blocked all the connections that are not on the list of allowed apps. Public network would be network 2. Notification state, do not notify me when Windows Defender blocks these things, right? You can change your notification settings. You can allow an app or feature through a firewall, and then you can see that this is the list of the apps that are available here, and then you have the options right on the right hand side. So these Windows device management would be allowed on private and public networks. Windows security is allowed on private and public networks. Let's see if there's anything that, I mean, all of these things that are not checked, that means those are technically not allowed, right? So remote desktop WebSocket should not be allowed on either private or public networks. You don't want people to remote desktop into your computer in any case, unless you actually specify that those things should take place, right? So you can see how these things, essentially anything that's been checked is allowed, and anything that is not checked is not allowed. And so here's one that is only checked for the private network, which is the dial protocol server. Let's see, what else do we have? I think that was actually the only one that was allowed on the private network. Everything else has been blocked, or everything else is either allowed both on public and private, or has been blocked completely on both ends. So that's it for the allowing of rules, or changing the allow or blocking of rules, which is right here. And then we can turn the Windows Defender Firewall on or off, and then we can restore the defaults, meaning restore to all of the default rules, which is what I presume the current rule set that is on this machine would technically be considered the default rules, because I haven't made any changes. So if I do make any changes, and then if I click it to restore defaults, it'll just going to reset it and restore it to its original default settings. So what we can do, or now that we understand this, now we can actually go ahead and create a couple of custom rules, because I think we do need to get some flags and some responses to some of our questions. Now, the first thing that we need to do to test this custom rule that we're going to create is we are going to first visit a web page. So I'm going to go ahead and open my Internet Explorer here, and then we're going to browse to a specific IP address, and then we should be able to access it because we haven't created any rules for it. And then from there, we will set up the rule. So the IP address is going to be http://10.10.10.10. Very fancy, very crazy. So if you can see this page, you're connected to TryHackMe, flag connection verified. So do I even need that flag? Let's see if I need that flag. I don't need that flag. It's not one of the answers that we need. So that's fine. The next thing that we're going to do is now we're going to create a custom rule to block it, I believe. So we're going to go to advanced settings, which will actually take us to the advanced version of the Windows Defender, which I already had open. So it should be this guy right here. Boom. So if we go over here, and if we click on advanced settings in our control panel, Windows Security Firewall or Windows Defender Firewall, if I click on advanced settings, it should just automatically take me to this, or I guess it's going to reopen another one, which is kind of redundant because I'll literally have it open right here. So this is the advanced version of the Windows Defender Firewall. So Windows Defender with advanced security. Fancy. All right, so on the left-hand side here, as we established at the very beginning, is the inbound and the outbound rules. So we can create new inbound or outbound rules. So we're going to create one to block all of our outgoing HTTP and HTTPS traffic. So we do that by clicking on the outbound rule. And then from there, we're going to, let's see, click the outbound option, and then on the left side you're going to click new rule on the right side, and it will open the wizard to create a new rule. So this is on the left side. We're going to go over here, we're going to click new rule on the right side, and it should open up a wizard for us to create the rule. So here we go. This is the actual wizard. The wizard is here. Cool, so we are going to create a custom rule, and from here we're going to move forward. And what is the custom rule supposed to be here? So it says all of the programs is going to be selected, and then we're going to click next. And then in the protocol type, we are going to choose, let's see, TCP as the protocol is what the instructions tell us to do. And then we're going to keep the local port as it is, which is supposed to be all ports, and then change the remote port into a specific port option right there. And then that remote port is going to be, let's see, write the ports in the field. In our case, is going to be 80. And then we're going to do comma and 443 because we're blocking everything outgoing that would be for HTTP. So that would be port 80 and port 443. And then we're going to click next. And then it's going to say which local IP addresses does this apply to and which remote IP addresses does this apply to. And separate the port numbers by commas and please don't leave spaces between them. That was the last note that they gave me. Okay. And I think that's pretty much it because there's literally no other notes after that. So after just doing those ports, I think it pretty much applies to everything. In the scope tab, keep the local and remote IP addresses as they are. Press the next button. In the action tab, enable the block connection. So there we go. That's what we got. Block connection, that's already been enabled. And then press next. That's all good too. And then in the profile tab, which is where we are, we keep all the network profiles checkmarked. Lastly, the final phase is to give your rule a name, and it's going to be the name. So what are we going to do? We'll do block HTTP and HTTPS traffic. That's all we're doing. And then we're going to click finish on this bad boy. And now we should have a rule. Look at that. Block HTTP and HTTPS traffic. It worked. We created a new rule. And then we can look at the info here. So the profile is everything. Yes, it is enabled. The action is to block it. There is no override. Any program at any address on any remote address, TCP protocols, any local port is any remote port would be 80 and 443, and authorized computers, any, authorized users, any. So that's great. Cool. So that actually worked. And now if we went back into this thing right here and pressed enter, it's going to say it should not be working. It should be blocked. See, something is wrong. Okay, so the only edit that I made to actually make this work was I went over here and I removed the space between the ports. So if we go to ports and protocols right here, notice how it has the space again, even though I deleted that space, and I went down here and I clicked apply, and that's the rule, and I clicked OK and everything, right? And then I came over here and this thing is actually right, and it didn't work. It said can't reach page. And then we're going to try it again, press enter, and it still does the same thing, can't reach page. So that's the only error that I saw, was that the ports and protocols, which again, like every single time that you open the thing and you refresh it, it has removed that, it's added that space. And so that space needs to be removed, and then you press apply, you press OK. And then as long as you don't go back into it, the rule doesn't get changed or anything like that, and then it'll actually work. So that's basically the only thing that I had to do to just make sure that this works. And that is officially it for all of the instructions that they gave us on this exercise. So let me make sure. Yeah, that's the last step. So we just needed to make sure that that website was blocked. So now let's bring this back up to the screen here, and then let's answer these questions at the bottom that we got. So it says, what is the name of the rule that was created to block all incoming traffic on the SSH port? I mean, I already know this, so it's going to be deny 22. Oh, it's not, huh? Okay. So all right. So let me go open the machine back up. I hope I didn't cancel the machine out, because then I would have to wait for it to restart and do all that. Actually, we could do show split view, and the machine should still be there. And so now what we need to do is go into our advanced settings and then look at the advanced rules again. So we want, what is it? What is the name of the rule that was created to block all incoming traffic on the SSH port? So that's going to be under inbound rules. So we're going to click on inbound, and then we want all incoming SSH. So let me see if I could find that. Okay, so I just brought the local port column a little bit closer to the action so that I can try to analyze it without having to slide back and forth. And so there's only two rules that have to do with the SSH port, which is port 22. And so the one that says block is the core op rule. So I was way off. So core op is the name of that rule. And now it says a rule was created to allow SSH from one single IP address. What is that rule name? So it's the very next one right here. And that is the infra team. I'm assuming that's the infrastructure team. So infra team would be that rule. And which IP address is allowed under this rule? So we're going to just open this thing up and go look at the IP address. So that would be under scope. And that is the 192.168.13.7. So 192.168.13.7. And that is it, baby. Okay, cool. So now we can actually go into the Linux IP tables. And I wonder if we're going to actually run any of these things, or if we're just going to read the instructions. So let me check to see if we're going to do this using our attack box, or we're just reading through this stuff. Okay, so there's actually no attack box for this. There is no machine that we're going to end up using for this, but this is it's fairly simple. It's like a really easy read through. If you are interested in learning about the uncomplicated firewall, which is UFW or IP tables, I highly recommend you check out the Linux Plus training series, the Linux Plus playlist that's on this channel. There's also the last video on that playlist that goes into scripting, and we actually create a couple of scripts for automating some of our interactions with our firewalls. So you can you'll learn a lot. You'll learn the basics as well as some of the most intermediate or more intermediate advanced stuff as well. So the Linux version of the firewalls is what we're going to be talking about right now. NetFilter is the framework that's inside Linux OS with core firewall functionalities, including packet filtering, network address translation, and connection tracking. And this serves as the foundation for various firewall utilities available to control network traffic. Some of the common firewall utilities inside of this framework, or the ones that utilize this framework, are IP tables, NF tables, and Firewall D. And IP tables is the most widely used in many distros, and it uses the NetFilter framework that provides various functionalities. NF tables is the successor to IP tables utility with the enhanced packet filtering and network address translation capabilities, and it's also based on the NetFilter framework. And Firewall D is operating on the NetFilter framework and has predefined rule sets. It works differently from the others and comes with different pre-built network zone configurations. Then there is UFW, which is the uncomplicated firewall. And as the name implies, it's actually very, very simple to create rules with this. So IP tables actually has a much more complex syntax compared to what UFW uses. And if you want to know what that is, go check out the Linux Plus playlist, because we create a bunch of different rules, and it is definitely much more complicated than the UFW, the uncomplicated firewall syntax. So it's more beginner friendly, UFW is, and basically whatever the rule that you need, you can actually define them with some easy commands via UFW, which would be configuring the desired rules in IP tables. So we can look at a few of these things. So number one, you would use sudo, which is an administrator command that allows you to interact with your machine as an admin. So that's one of the big things that you need to keep in mind. Everything that we're going to do, or everything that you would do with a firewall, you need to do as an admin. Otherwise, none of this stuff is going to work, right? So at the same time, you need to be careful with everything that you do, because you're doing it as an admin and you're making system-wide changes that can potentially be hazardous if you don't know what you're doing. So we have sudo UFW status, and it just tells you the status of UFW. So in this case, it's not active. If it was active, it would say active. Then you do UFW enable to actually activate it. So now it's going to say firewall is active and enabled on system startup. So to turn it off, you would just say disable instead of enable, and boom, you're good. So then we're going to create some rules, right? So in this particular case, the default in our command means that we are defining this policy as a default policy, allowing all the outgoing traffic unless we define an outgoing traffic restriction on any specific application in a separate rule. And you can also make the rule allow or deny into the machine by replacing outgoing with incoming, and that's fairly standard. So sudo ufw default allow outgoing. So default allow outgoing means by default allow all outgoing traffic. Okay, that's the rule. Now we can deny incoming traffic at any port on the system. So let's say that we want to block incoming SSH. So we would say ufw deny 22 TCP. Very simple. And as you can see, we specify the action, which is deny. And in this case, we've specified the port and transport protocol, which is TCP port 22. And this is the syntax, sudo ufw deny 22 TCP. Very, very simple. And then it adds it as IPv4 and IPv6, which is also very, very handy. And so if you want to list the rules that you have, you do sudo ufw status number. The number part is highly recommended. It gives a number to the actual rule, and when you want to delete something, you would give it the number, because you would have to give it the full rule if otherwise. So it's just much more handy if you use the numbered at the end of status, just so you can see what the status of the firewall is and what the status of all of the rules are, and then what the number is that is associated with that. So in this particular case, sudo ufw status numbered gives us two rules, because we created the two rules here. Technically we created one, but it's doing it for IPv4 and IPv6, so that's what you have, right? So you have the version for 22 TCP on IPv4, deny incoming or deny in, and then you have 22 TCP on v6, which is IPv6, and it's also denying incoming from any location, right? So to delete any of these things, we could just say sudo ufw delete 2, and it will delete this specific rule, which is in position 2, and then you want to put proceed, yes I do, and then you would delete, it says that rule deleted v6, right? So there you go. These different utilities can be used to manage NetFilter. Choosing the right utility for the Linux OS depends on the multiple factors, such as the familiarity with the OS and your requirements. You can test your knowledge of Linux firewalls by creating some rules defined in this task and testing them to ensure that they are working as expected. And if you have access to a Linux machine, I would highly recommend that you actually try it, because it's pretty fun and it's very, very easy. It's literally as simple as you see inside of these commands. And again, there's more detailed explanations inside of the Linux Plus playlist in case you are interested to learn more about it. So which Linux firewall utility is considered the successor of iptables? And that would be the, what was it? It was nftables. And then what rule would you issue with UFW to deny all outgoing traffic from your machine as a default policy, and do it without sudo? So it would be UFW default deny outgoing. Boom, baby. And that's it. We are officially done, and we completed the firewall fundamentals room. So I mean, I hope you can see how simple this was. It really wasn't that complicated. Firewalls are actually not complicated compared to I would say a SIM or an intrusion detection system or something like that. Firewalls are actually much simpler to configure and to install and to associate with. At the very least, you know, UFW is, or at the very least, the Windows Defender tool is, because Windows Defender actually has a wizard that guides you through all of those things. So in that regard, firewalls are fairly simple. If you want to set up iptables, on the other hand, the syntax is a little bit more complicated than what we just saw with UFW. But even in that regard, I still think that it's a pretty easy tool to learn how to use compared to Splunk, for example. So that's pretty much it. That's all we got for the firewall fundamentals video. If you got value from this video, and if you would like to get more videos inside of this playlist, which is our CySec101 playlist, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out inside of this playlist, and the next time that a video comes out on this channel. We do have a pretty active channel. I gotta be pretty honest about that. I actually love this community. It gets very, very active in the comment section. Our Discord chats are also really active, and it's really nice. And you know, I create videos like this, which are super introductory, and I also create videos that are the Network Plus version of things. So I just did the Network Plus training series that just came out, and then the next major training series that's going to come out is going to be the AI for cybersecurity. And then along with that, I think like in tandem with that, I'm going to do like a pen test plus or a guide to pen testing also that's going to end up coming out. So I think that's going to be pretty powerful as well. But I'm creating stuff. I'm creating more and more videos as the days and weeks go by, because I genuinely love teaching and I love sharing this information with people who actually want to learn it. So if that's you, make sure that you like, subscribe, and turn on the notification bell. And of course, drop a comment if you have any questions or if you have any errors with anything. I'm very responsive in the comment section. I answer everybody's comments, usually at least within a day. Sometimes it gets past me and I miss it for like a week or two, but I respond as quickly as I see the comments, because I'm responding from my phone most of the time. So I will respond as quickly as I possibly can. But anyways, that's kind of the whole thing with this. So like, subscribe, turn on notification bell, drop a comment, and make sure that you say hi or ask a question, whatever you got. Yeah, that's it. If you'd like to support this channel and get access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets its own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, bug bounties, exclusive downloads, monthly Python automations, live streams with me, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@hankhackshackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in our Discord chats. If not, I hope I see you in our comment section. And that's it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. I almost broke my mic, and I'll see you in the next video. Later.